Video tutorial, I'll be explaining the solubility product expressions and the calculations involved with KSP. So to begin with, the solubility product, KSP, of a compound is the product of the molar concentrations of the constituent ions, each raised to the power of its stoichiometric coefficient in the equilibrium equation. So, for instance, I have here three examples. Magnesium fluoride. So, what are the constituent ions of this insoluble salt? MgF2. So, MgF2 is composed of magnesium ion and the fluoride ion. Now, why I wrote 2 here? You always, when you look at the salt, you have to see the stoichiometric, the subscript made up of. So here I have 1 Mg and 2 F minus, because 1 F minus is not enough. And how do I know this? You just use the help of the formula. Always identify the first positive ion, and then the rest would be for the negative ion. And be careful if there are power. So here Mg2 plus and 2F minus. So when I write the KSP, it is going to be the concentration of Mg2 plus, the concentration of F minus raised to the stoichiometric power of F. So here, this 2, it is a power. Now let's take another example. Ag, silver carbonate. So when we first identify, take this as a rule. Identify first the metallic ion. Ag plus is a metal, so it makes a positive ion, and the rest would be all negative. Now, if we are dealing with a polyatomic ion, the polyatomic ion, if there's a subscript to it, if there will be some stoichiometric coefficients, you will see this polyatomic ion written in between parentheses. Now here, the CO3 is not written between parentheses. This means that we have one CO3. But if I had this formula saying like that, it means that I have 3 CO3 2 minus. So always be careful. If the polyatomic ion given to you is written in parentheses, like this example over here, it means you have 2 of it. If it's not written in parentheses, and this rule is only for the polyatomic ion, it means the stoichiometric coefficient is 1. Now silver, we have 2 of it, so we write 2. When we write the KSP formula, we have silver concentration and we have CO3 concentration. However, the silver will be raised to the power of 2 and the CO3 2 minus will be raised to the power of 1. If there is nothing written above the concentration, it means that this is power 1. Taking a third example, calcium phosphate. Where's the first metallic ion? It's calcium. So it's Ca2 plus. Calcium belongs to group 2. Now the PO4 is in parentheses and there is 2 here. It means that I have 2 phosphate ion. And this phosphate ion, when we write the concentration, it must be raised to the power of 2. Now calcium, I have 3 calcium. So when I write the concentration, it must be raised to the power of 3. I'm going to give you 3 more examples. Saying we have silver chromate. Looking at silver chromate, here's the polyatomic ion, and here is the metallic ion. Is the polyatomic ion written in parentheses? No. It means I have 1 CrO4. Now I'll tell you about the charge in a minute. And when I write the KSP, the concentration of CrO4 is going to be to the power of 1. Now, the first ion is silver. and silver is always known to be positive 1. So here I have silver, and this silver is, we have in this ionic compound, we have twice the silver, so it's going to be raised to the power of 2. Okay, now the last thing information I need to know is the charge of this CrO4. Now ask yourself, if silver is positive 1 and I need 2 of it, it means that the total charge is 2 plus, therefore the charge of the Cr4 is 2 minus. And here's the formula. Let's take another example. Aluminium hydroxide, AlOH3. So when we write this formula, of course, the first ion having positive charge is the aluminium, and the second ion having negative charge is a polyatomic ion with inside parentheses. It means that this 3 is a stoichiometric coefficient. I have a 3 OH. Hydroxide ion is known to be OH minus, and aluminum belongs to group 13 with the 3 plus. So we have 1 aluminum and the 3 OH. When we write the KSP of this compound, it is the concentration of Al3 plus multiplied by the concentration of hydroxide ions raised to power 3. Now, one more example. Last example in this video tutorial, barium phosphate. Again, I have a polyatomic ion inside parentheses. Now the 3 and the 2, these are going to be the stoichiometric coefficients in this equation. So I have barium to be positive 2 because it belongs to group 2, and phosphate 3 negative. And when I write the KSP formula, it's going to be barium raised to the power of 3 and multiplied by phosphate raised to the power of 2.